się nazywa trochę cyfrowy bliźniak, albo to jest mega temat, powiem wam. Tylko, że to jest stare jak świat. Ja znalazłem teraz na przykład Corbett Report, on mówił o tym 13 lat temu. Znalazłem artykuły z roku 2007, które mówią, że Department of Defense zakłada coś takiego w Stanach Zjednoczonych. Znaczy znalazłem, to wszystko jest, tylko ja się tym nie interesowałem, nie? Że oni to mają stary od dawna i to polega na tym, że oni mają symulację praktycznie 1:1, jakby lustrzane odbicie naszego świata. Każdy z nas, wszystkie dane, jakby płatności w real time, wszystko jest tam, wiecie, zapisywane, rekordowane, nie? I mają po prostu jakby lustrzanego sobowtóra, takiego cyfrowego, wirtualnego sobowtóra każdego z nas. Oni mają już wtedy mieli, nawet tam już ileś dekadę temu mieli chyba taką symulację, czy w 2007 już symulację 60 kilku państw, nie? To oni tam robią jakieś takie numery, że na przykład wiedzą, co się stanie, jak na przykład zakręcą wodę na jakimś obszarze albo coś, także wiecie, jest opcja, że te wszystkie kryzysy, to oni je już dawno rozgrywali, oni to, wiecie, na swoich komputerach, tak jak na przykład te Dawidy 19 i to wszystko, nie? Że to mi też tak wyglądało właśnie, jak taki, jakby oni, wiecie, oni na przykład mogą zrobić blackout, nie? Powiedzmy w Berlinie teraz był chyba blackout, czy w Hiszpanii wtedy. I oni mają, wiecie, zbierają wszystkie dane, oni mają wszystkich ludzi pod komórkami podłączonych. Oni mogą modelować, oni robią sobie taki blackout w jednym mieście i patrzą, co się dzieje. Wtedy już mają model takiego blackoutu. Wiedzą, co na przykład się stanie, jak w jakimś innym mieście odłączą prąd, jak to będzie wszystko działać. Bo nie mamy w ogóle pojęcia, ile oni mają wiedzy na ten temat, nie? Ale to z tym właśnie, jedno się nazywa SWS, to jest jakiś tam Simulation World, coś tam, Sentient World Simulation. Nie? To jest chyba to najstarsze w ogóle, to ma naprawdę już chyba grubo ponad 2 dekady, jak oni o tym w ogóle oficjalnie mówią, nie? No i w ogóle jest, powiem wam, że no beka, bo widzieliście teraz ten filmik z tym byłym premierem Wielkiej Brytanii, co szedł za tym samochodem i miał tą czerwoną teczkę, jak wyszedł z samochodu, to mu się zielona zrobiła. Ja to tego ziomka na TikToku widziałem, taki sympatyczny pan z brodą.
Trafiłem właśnie na mega ciekawy film. I to nie jest żadne AI i żaden fake. Można sobie to sprawdzić. Materiał pochodzi ze Sky News i zobaczcie teraz, jakie są możliwości robienia nas w chuj. Zauważyliście, co się stało? Na przykład w magiczny sposób was
I on zakłada, że oni tą AI mieli już o wiele wcześniej, no bo chociaż to nie było aż tak dawno, bo ten Sunak chyba się jakiś Anshi Sunak, czy jakiś taki chyba chińskiego pochodzenia. On był chyba 22-24 premierem. Nie pamiętam dobrze, musiałem teraz sprawdzać, nie chcę. Także to nie było aż tak dawno, ale wiecie, że jest opcja po prostu, że oni te filmiki, to jeszcze dzisiaj stary cały czas łapie na tą AI, nie? Teraz, znaczy, chcę dokończyć, że oni to już znacznie wcześniej mieli, nie? Że możliwe, że pełno rzeczy, które my oglądamy są AI-em zrobione od lat, a my nawet o tym nie wiemy, nie? Ale była taka opcja tylko, ale no teraz się złapałem na przykład taki, nie wiem, taka babka pokazuje, wiecie, są takie filmiki, jak ludzie robią z tej żywicy, jakieś coś tam zalewają żywicą, takie stoły, nie? Coś tam, na przykład stare deski zalewają, albo jakieś tam kwiaty. I tutaj ja oglądam, i tak zaczęło mi się dziwne, już któryś filmik oglądam i dopiero po jakimś razie zaczęło takie dziwne mi się wydawać. I rzeczywiście w komentarzach patrzę, że to kurczę AI. Mało tego, teraz jakieś budowy, takie timelapsy z budów, nie? Też zaczęli robić na AI. To normalnie, no nie wpadłbyś na to, stary, że te dziki w Polsce też, nie? To wszystko jest na AI robione, stary. Ja też co chwilę wpadam, powiem, ja się śmieję z tych ludzi, którzy nie widzą takich jaskrawych rzeczy, ale ja, stary, daje się codziennie praktycznie nabrać, nie? Ciągle jakieś nowe pomysły ludzie mają. No, ale poczekajcie, wracając do tych tematów. No właśnie, no bo to wszystko się, ja chciałem robić właśnie o tym raporcie, czy jakby media, takie banie i oni telematycznie przewidują, kto popełni przestępstwo, a ten Tom Cruise jest takim policjantem, który później jedzie i łapie tych ludzi, czy coś. Ja gadam 18 minut. No i to się jakby po części już dzieje. Tam Palantir gra dużą rolę. W Kanadzie to się dzieje, ale się okazuje, że w Kanadzie to jest pikuś, bo w Chinach, no to też się ciekawe rzeczy dowiedziałem, nie? Że od 73 roku w Stanach Zjednoczonych w ogóle uznano, że nie rehabilitacja, tylko resocjalizacja więźniów, czy osób karanych, czy przestępców jest absolutnie bezsensowna. Jest jakiś raport, który nazywa coś tam Nothing Works, takich 2 psychologów i no i że oni statystycznie będą, według statystyk. No a teraz ocenią, nie, czy to zależy, czy na przykład czy kogoś wypuszczą, czy na ile pójdzie do więzienia, czy jakieś tam obostrzenia dostaje i tak dalej. Także w ogóle nie ma resocjalizacji już w Stanach, a u nas cały czas jest w Europie, nie? W Europie, w Polsce, bo właśnie mnie zdziwiło, tak zacząłem tam robić liceum, bo koleżankę, wiecie, jak wróciłem z Niemiec, to taką koleżankę spotkałem z liceum i właśnie pamiętam, że ona mówiła, że ona tam później nie rehabilitacji, tylko resocjalizacji pracowała, nie? I tak mi się właśnie przypomniałem, myślę, jak to? Oni od 73 roku, a ja mam koleżankę, która jeszcze już niedawno pracowała przecież w tym. No tak, masz rację, bo tam Europa ma takie humanistyczne podejście bardziej. No, to było ciekawe, co odkryłem. No, ale wracając do tego, to się nazywa pre-crime, nie? Znaczy crime to jest przestępstwo, to pre-crime, czyli właśnie, no oni niby tam używają statystyk, tak, ale właśnie przez to, że AI wchodzi i te symulacje oni mają, że to będzie, no, gorzej. Ale mało tego, słuchajcie, to, że służby to mają i jakieś takie wojska, żeby tam jakieś to jest jedna rzecz. Na przykład nie wiem, czy służba zdrowia, czy ubezpieczenia, ale coś takiego, jeśli chodzi o twoje zdrowie, też takie rzeczy robią. W Polsce nawet też jest jakiś taki model. Nvidia w ogóle ma jakiś, to się nazywa coś tam, Europa ma też swój własny model. No powiem tam o tym, nie? To też się jakoś tam nazywa. Właśnie model takiej symulacji całego, nie wiem, czy świata, czy Ziemi, czy tylko Europy, ale chyba to oni też mają właśnie taką symulację Ziemi, tylko oni coś tam pieprzą o klimacie, nie? Że oni tam klimat, a klimat jest, wiecie, to taki skomplikowany, że to jest mało możliwe go symulować, że to jest lat, chmury mają dużo w obliczaniu, w modelowaniu klimatu, wiecie, te oceany, prądy oceaniczne, tych elektrycznych zjawisk oni w ogóle nie umiają, a widzieliście w tym filmie, jak się podzielił, to wszystko elektryczny. Także no to modelowanie klimatu jest raczej mało wiarygodne, nie? Bo to jest przede wszystkim mega skomplikowana rzecz. Już kiedyś jakieś komputery sobie nie radziły z tym nigdy i ten. Dobra, ale wracając do tamtego. Jeszcze Nvidia ma też własny taki, podobno stworzyła też własny taki model lustrzonego odbicia świata. To się tam też jakoś inaczej nazywa, tylko oni chyba, nie wiem, czy oni coś tam było z miastami, że oni mogą wtedy przewidzieć, co się w miastach dzieje, wiecie, jakieś tam wiatry, przewiewy,
nebulae revealing the secrets of a universe at large. These are some of Hubble's greatest discoveries. The Hubble telescope is a bus-sized satellite, which launched into space aboard the Space Shuttle Discovery in 1990. Rising high above Earth's atmosphere, it is able to study our universe in crystal clear resolution, unhampered by atmospheric disturbances and absorption which constrains the potential of ground-based telescopes. Hubble resides in a low Earth orbit and faces outwards towards space, studying the universe predominantly in the visible and ultraviolet wavelengths, but various upgrades over the years have broadened this capacity to the near infrared. As mentioned, Hubble has taken more than 1.5 million observations of the cosmos for more than 12,000 scientific endeavours, its findings being cited in more than 20,000 peer-reviewed papers, some of them yielding the most important information we have about our universe. Hubble has seen generations of stars birthing and dying in spectacular supernovae. It has seen the ghostly emissions of the universe's earliest galaxies, grinding out the first stars at breakneck speed. And it has seen the universe expanding at what appears to be an accelerating rate, with seismic implications on its ultimate fate. As such, the Hubble telescope has single-handedly defined its own era in astrophysics, an era that now overlaps with that of its successor, the James Webb Telescope. But with such a long, rich history of revolutionary research, it's easy to view Hubble's time in the sky as one long, unceasing success. However, this is far from the reality. In fact, the telescope has had to overcome a number of hurdles during its service, many of which arose in its early years of operation. Remember all those long, painstaking delays to the James Webb Telescope, holding it back year after year? Well, the caution shown by scientists was not without reason, because even the slightest, tiniest fault in an optical instrument can fundamentally impair its ability to make observations. And this is exactly what happened with the Hubble telescope in its early years. A month after launching, Hubble switched on and became operational. And initially, test photographs of its first light did show an improvement on the images produced by ground-based observatories. However, within a year, NASA had announced that the initial images being received from the telescope were blurrier than expected, with stars cloaked by fuzzy halos of skewed light, making clear, precise detail difficult to resolve. An internal investigation traced the problem all the way back to the development of the telescope's spherical 2.4-meter primary mirror. Unbeknown to its engineers at the time, the mirror's curvature was marginally off, with a spherical aberration of about 2 microns. While this deviation equated to only about a 50th of the width of a human hair, the mirror was left unbalanced and improperly calibrated for the optical instruments using its light, particularly the wide-field planetary camera, intended to be Hubble's workhorse camera unit. With such fine margins impairing the observatory to such a degree, you can see why scientists were keen to take their time to make sure they got the James Webb Telescope right. The Webb Telescope's position in an orbital zone trailing the Earth makes it effectively impossible to reach the telescope for repairs now it has been deployed. However, the Hubble telescope's low Earth orbit did place it within reach of humanity, and thus NASA scrambled to assemble a servicing mission aimed at salvaging their flailing vision for a pioneering space-based observatory. In the meantime, however, despite the shortcomings of the optical instruments, Hubble remained an unrivaled tool for cataloguing and measuring the distances to the brightest extragalactic stars. Cepheid variable stars are volatile stars that pulsate radially on periodic timescales, causing them to vary in size and luminosity on a well-defined basis that can be used as a cosmic benchmark for constraining the distance. This was the same technique used by Mount Wilson astronomer Edwin Hubble, who used Cepheid variable stars to prove beyond reasonable doubt that the so-called Andromeda Nebula was actually an independent spiral galaxy lying at least 1 million light-years beyond the Milky Way. And in mid-1993, Hubble's namesake telescope used this method to precisely measure the distance of another nearby spiral galaxy, Messier 81. Previously, scientists couldn't agree on whether this galaxy was 4 million light-years away or 18 million, as no reliable method could yield precise results. But the Hubble telescope was able to identify Cepheid variable stars in M81, accurately measuring its distance to be somewhere in the region of 11 million light-years from Earth. And doing so, scientists took a major step towards determining the age of the universe. In fact, it was Edwin Hubble himself who demonstrated that a linear relationship exists between a galaxy's distance and the speed at which it appears to be moving away from the Earth. This recession is due to the universe's expansion pushing galaxies apart, and thus, if we know how far a galaxy is from Earth precisely, we can compare that to how fast it appears to be receding to accurately constrain an estimate for the Hubble constant. which the telescope found to be around 73 kilometers per second per megaparsec. And finally, armed with their first precise estimate, scientists were able to extrapolate this expansion backwards to a point where they could go no further, deriving an estimate for the age of the universe as around 13.5 billion years. This placed a firm marker in the sand amid an ongoing debate over whether the universe was 10 or 20 billion years old. And this precise age of 13.8 billion years is a figure that has been rigorously reaffirmed by independent experiments ever since. As 1993 drew to a close, NASA finally embarked on their first servicing mission to Hubble, as astronauts aboard the Space Shuttle Endeavour visited the telescope in orbit to deliver and install replacement components. While not feasible to replace the flawed primary mirror itself, the shuttle crew were able to swap the internal optical instruments with updated versions implementing their own corrective optics, the same way glasses would be used to correct the vision of a long-sighted person. In space, the shuttle crew had to gently open Hubble and remove its large internal instruments, with the subtlety and delicacy of handling a sleeping baby. They replaced the unfocused wide-field planetary camera with the updated WIF-PIC 2, adjusted and primed to work with Hubble's tricky mirror, able to observe.
On July 20th, 1969, at 10:56 p.m., Neil Armstrong became the first human to step into another world, the moon.
That's one small step for man, one giant leap for mankind.
We may possibly witness such an epic moment on Mars very soon.
From a technical point of view, we're much closer today to being able to send humans to Mars than they were to being able to send men to the moon in the 1960s.
This might be just the prologue to one of mankind's greatest challenges, settling on a world away from Earth. A space colony on Mars might become a reality in the near future. The Earth might well become uninhabitable due to climate change or the impact of a huge asteroid.
We have the probability that a big asteroid might hit the Earth, like it was done in the past when the dinosaurs died out.
The only way to guarantee the survival of our species may be to create a new home off Earth. The amazing discovery of huge amounts of water has boosted interest in Mars, putting it in the spotlight. NASA and ESA, the European Space Agency, and private companies such as SpaceX are already working on projects for settlements on the Red Planet in the coming decades. But it won't be an easy road. Mars is so far from Earth that the spaceflight would be about 6 to 9 months, involving long exposure to cosmic radiation and zero gravity. We will also need to overcome the engineering difficulties of landing on Mars due to its thin atmosphere. That future colony on Mars will need effective shielding, as the ionizing radiation that reaches the surface is extremely high and would be lethal.
The atmosphere is so thin that if you were not protected by a spacesuit and by accident you were exposed to the atmosphere of Mars, your blood would boil instantaneously.
All those difficulties make the construction of a permanent settlement on Mars a huge, unprecedented technological challenge.
This is a game where you have to do everything right and roll 7-11 or doubles.
Our descendants, who might live on Mars, will remember the moment they established the first space colonies one of the greatest milestones of humanity. Since human beings first ventured into space, they have dreamed of being able to live on their planet. Among all the planets, there is one that is considered one of the best targets for possible human colonization: Mars. Its surface conditions and the presence of water on Mars make it the most hospitable planet in the solar system, other than Earth.
Mars is the most similar planet in terms of environmental circumstances, and it is the one that has the most resources to support human settlement.
Since the first close-up pictures of Mars by Mariner 4 in 1965, several NASA spacecraft voyages to the Red Planet have revealed a very familiar world.
If you look at the landscape on Mars, it looks like Australia or Arizona. It's a red-colored rocky desert with a lot of sand. And we have that in many places on the Earth.
Like Earth, Mars has polar ice caps and clouds in its atmosphere. Seasonal weather patterns, dunes, mountains, canyons, and other recognizable features. This similarity of our neighbor planet to Earth have aroused the curiosity of the scientific community and kicked off a whole series of missions. Since the 1996 launching of the Mars Global Surveyor probe, NASA has developed the Mars Exploration Program. The goal of this program is to provide scientific information through a series of robotic orbiters, landers, and mobile laboratories. The first aim of that program was the program's science theme, Follow the Water, as the water is a key factor for life as we know it.
On Earth, there's a one-to-one connection between life and liquid water. And so instead of looking for life directly, NASA's doing with its partners the easier thing first, which is to look for water.
Several missions from 2001 to 2007 made progressive discoveries related to evidence of past and present water in the geologic record that make it possible to take the next steps toward finding evidence of life itself.
I want to find out if there is alien life there. Of course, not big aliens, tiny little microbes, because it would be the first example of an alien form of life that we would find. And Mars is a good place to go look for that.
In 2011, NASA's Curiosity rover marked a transition between the themes of follow the water and seek signs of life. In addition to landing in a place with past evidence of water, Curiosity was seeking evidence of organics, the chemical building blocks of life. The ExoMars mission, a mission of the European Space Agency, ESA, in collaboration with NASA and NASA's Mars 2020, will finally try to discover if there is or has ever been life on Mars by searching for life itself in places identified as potential habitats. Finally, the third phase of the NASA's Mars exploration program is to prepare for human exploration.
That already started. We're already planning the human exploration of Mars. I personally hope that it will happen in maybe the late 2030s.
This first manned mission to Mars will meet a milestone for humankind. This was the 1969 moon mission. When this happens, we will be able to say that our path to the colonization of Mars will have started.
curiosity and passion for exploring new worlds knows no limits. We always want to go beyond our boundaries. The origin of this impulse answers the need of the species to find new habitats that encourage its development. Now, our next frontier is beyond the Earth. Space colonization is the next logical link in our evolution as a species. Beyond the Earth, there are a huge number of resources that we could benefit from to keep growing.
This is a way that the human population can grow and thrive for thousands of years. We can clean up the biosphere, and humanity can expand into the solar system.
Space expansion and colonization might be the beginning of a new era for humankind to reach an unprecedented level of development. In addition, it could be the only way to avoid its destruction by external causes, even self-destruction. The choice could be, as H.G. Wells said, the universe another threat. The danger of an asteroid impacting our planet is real, and
likely to happen tomorrow or even in our lifetimes, but it is definitely going to happen sooner or later, and so it would be best if we were prepared for that.
a permanent base beyond the Earth would guarantee not just an alternative home in case of need, but also access to a huge number of resources out there. Mars, due to its characteristics, is considered one of the best possible places for that future permanent base off Earth. Other places like the Moon or the asteroids are also considered possible targets when it comes to taking the first steps toward becoming a multi-planetary civilization. Several private companies are developing projects to extract resources and rocket propellant from asteroids. What is more, the discovery of water on the Moon has led to the development of concepts such as the Moon Village, proposed by ESA, the European Space Agency, to carry out activities based on the exploitation of resources and scientific research. Nevertheless, to establish a permanent colony that may become a future home for human beings, Mars offers several advantages over the Moon or other places. Mars is bigger than the Moon and also has more resources that we could take advantage of. So it's better suited to improvements to turn it into the home for a self-sustaining civilization. While the Moon has no atmosphere at all, Mars has the advantage of having some atmosphere, composed primarily of carbon dioxide, about 96%, with other gases such as argon and nitrogen, which means we can grow plants just by compressing the atmosphere.
Mars has water, frozen as ice, but and permafrost in the soil, but nevertheless there in large quantities. It has carbon dioxide, atmosphere, which is carbon and oxygen. That's what we need to make fuel. It's what we need to grow food. It has nitrogen, which life also needs. These things are extremely rare or completely absent, for example, on the Moon.
If we compare our own planet to Mars, they are surprisingly alike in many ways. Conditions on the surface of Mars are closer to the conditions on Earth in terms of temperature and atmospheric pressure than on any other planet or moon.
And the temperatures get to about 20 centigrade in the daytime at the equator, which is entirely acceptable. At night, it can get very cold, but it's not difficult to shield against cold by wearing a heated spacesuit. As different as they are from Earth, the conditions on the surface of Mars are acceptable for human exploration and settlement.
Mars, in comparison to the Moon, has gravity more like Earth's. While the Moon's gravity is 1/6 of the Earth's, Mars is 1/3. Thanks to studies done at the International Space Station, the only available laboratory of zero gravity, we know that the lack of gravity is a health problem in the long term. We suppose that having gravity much closer to Earth's will be favorable to settling a colony. A lunar day is 28 Earth days, whereas the Mars day is 24.5 hours, almost identical to Earth's. Also, Mars is about half as far again from the Sun as Earth is, so it still has acceptable sunlight. All these similarities between the two planets have led NASA and several private companies to start development of projects for manned missions in the near future. The NASA program Journey to Mars has been gathering data for several years, leading to a radical increase in our knowledge of the Red Planet and paving the way for future human explorers. Furthermore, private initiatives by aerospace transport companies such as SpaceX work with a clear goal: to colonize Mars.
That could take several generations of crews. Maybe the first mission will just set up the greenhouse, and then the second mission might start growing a few plants, but experimentally, They might eat them, but they're not going to rely on them. And then maybe it's only with mission number 10 that we'll stop bringing food from the Earth, and we're really going to count on the food that we bring from Mars.
To establish a permanent settlement on Mars won't just require a great deal of time, but will also mean huge technological challenges. Despite the surprising similarities to Earth, Mars is a hostile place for life.
As soon as you dig a little bit deeper, you realize that Mars is actually a very different planet compared to the Earth. It's actually lethal for human beings and most life forms that we know of on the Earth.
Human survival on Mars would require complex life support measures to be able to face the difficult conditions for life there.
The atmosphere is so thin that your blood would boil instantaneously. You would die of depressurization within seconds. If that did not kill you, well, the atmosphere is unbreathable. It's made of carbon dioxide. We need oxygen to breathe. That would kill you within minutes. If that did not kill you, then the dust is very fine cutting and also toxic, chemically toxic. That will kill you in a matter of several weeks.
One possible suggestion for making Mars conditions acceptable for the human beings would be to transform the planet, adapting it to the needs of human life. A concept that has been called terraforming. Terraforming would be a process of planetary engineering that allows the creation of a local biosphere similar to Earth's, making the Red Planet a habitable place for human beings.
The idea is to transform Mars into the Earth, to make the atmosphere thicker, to make the planet warmer with a warmer climate, to, over time, transform the composition of the atmosphere from what it is today, CO2, carbon dioxide, into oxygen.
Many scientists using climate models and ecological theories conclude that the terraforming of Mars is a feasible idea. With present technology, the climate of Mars could be transformed, making it capable of supporting life. Mars is now very cold. overly dry, and its atmosphere of carbon dioxide is too thin to sustain life. But these parameters are interlinked, and the three of them can be altered by a combination of human intervention and biological changes. If we could warm Mars up, we would once again have a thick atmosphere and liquid oceans.